I hope you had a good breakfast and all today. And how was yesterday's problem solving? Like, I sent you the PPT. I hope you tried the extra PYQs in that. Did you? But nobody reached out to me regarding any doubts, so I hope you were able to solve all of them. And today's topic is gravitation. So it's an important topic, as you know. We will start. Is the screen visible and my sound audible to you all? Just in 1 minute. How about now? Am I audible and visible? If there any issue, please put in a chat box or open your mic and tell. Okay? Connected. Okay, so we will start with the chapter gravitation. And for this chapter, a first thing we learn is Newton's law of gravitation. And it's a universal law. What is meant by universal law? It is obeyed by everything in this universe. Okay? And in this chapter, what else we will be learning? A gravitational field and potential, self-energy, that is gravitational self-energy of an object. Then variation of G with respect to different aspects, escape velocity, Kepler's laws, and lastly about satellite. In satellite, we will be learning about orbital velocity, total energy and all. Okay, so in these topics, as you can see, some are mentioned in green color. Those are the frequently asked questions from those topics. Okay, that's why it's mentioned in green color. Okay, coming to universal law of gravitation, what does it say? Every two objects in the universe are having a force between them, a force of attraction, and that force is proportional to the product of their masses and inversely proportional to the square of the distance between them. That is the law. From that we are getting this equation, force equal to G m1 m2 by r square, and the direction of this force will be towards the line joining both of their centers. Okay, so if this is earth and sun and line joining their centers is this, the gravitational force will act along that line. Okay, that is the direction of force. So since our Newton's third law says there are every action has equal and opposite reaction, both of them are attracted with the same force. Okay, sun is also attracted towards earth, earth is also attracted towards sun with the same force. But why we don't see that sun is not rotating about earth? Or let's say moon and earth, both are attracted to each other. Okay, or simply you take, if you throw a ball up, okay, that is being attracted down by the earth. Why is not going, earth is going up, getting attracted towards the ball? Okay, the reason is acceleration. Okay, acceleration is equal to force by mass of that particular object. If you take acceleration of the ball, okay, that will be force divided by mass of the ball. Mass of ball is very small. Then we can say that acceleration is very big. Okay, similarly, if you take acceleration of earth, that will be forced by mass of earth. Mass of earth is really big. So compared to the acceleration of ball, acceleration of earth is very negligible. That's why we don't see earth moving towards the ball. Ball is coming towards the earth. I hope that is clear for all. Am I not audible still? Okay. So coming to the next topic, principle of superposition. In first slide we learned that two objects are attracted to each other. Okay, what if multiple objects are there? Like all of them will be attracted to each other. Okay, so if you are taking this mass MO, there are other masses M1, M2, M3. All of them exert force on MO or M0. So total force on M0 will be F net will be equal to force due to M1 plus force due to M2 plus force due to M3, and it is vector addition. No, we are not adding the magnitudes. If you do vector addition of all forces acting on the object, we will get net force acting on it. That's what meant by superposition. Okay, there is no further explanation on this. I hope you also don't need that. Coming to gravitational field. As we already studied electrostatics, gravitation is going to be easy for you because most of these concepts you can connect with electrostatics. In electrostatic, our force equation is equal to K Q1 Q2 by R square. See, we can see the similarity, right? Here it is G M1 M2 by R square. Okay, by that comparison, you know that electric field is equal to force by charge. If that is the case, what will be gravitational field? Gravitational field will be equal to gravitational force divided by mass. Okay, which means gravitational field is the force experienced by a unit mass. Okay, force experienced by unit mass is called as gravitational field. Is that clear? Now if you see the equation for gravitational field, that equation will be G capital M by R square. This relation you can also see, this is also the equation for our acceleration due to gravity G. Acceleration due to gravity, in the context it is a different quantity, gravitational field is a different quantity. Both dimension, magnitude are same, but both are different quantities. Acceleration due to gravity, in the name itself it is there, it is acceleration of an object. Okay, gravitational field is force experienced by a unit mass object. Okay, so both are different quantities but same magnitude and same dimension. Now coming to like gravitational field, this you already knew. Like for plus charge and for minus charge you have drawn field lines. Same way for gravitational field also, but here is no like repelling, only attraction is there. That's why all the field lines are directed towards the earth. Okay, only difference between gravitation, like mathematical reasoning between gravitation and electrostatic is electrostatic attraction and repulsion is there, gravitation only attraction is present. Okay, coming to gravitational potential. Okay, again we can connect with electric potential, electrostatic potential. So electrostatic potential is work done to bring a unit charge from infinity to a point. So if you convert that to gravitation, it will be work done to bring a unit mass from infinity to a point. So work done is force dot dx, they substituted force, then find the final answer. So this is total work done. If mass is equal to 1, then work done will become minus gm by r. This is our gravitational potential. Okay, is that clear? Work done to bring unit mass from infinity to a point is gravitational potential. This is for a point mass. Now coming to gravitational potential energy. As we know, electrostatic potential energy is equal to VQ is equal to potential energy. So if you compare that formula here, gravitational potential energy will be equal to gravitational potential into mass. Okay, if we are not bringing unit mass, we are bringing a mass of m from infinity to a point, the work done will be potential energy in this case. Okay, so that's why we are getting the formula gravitational potential energy is equal to Gmm by R, minus sign is there. Okay, work done is positive, that's why potential energy will be negative. Okay, is there any doubt in this?
No, ma'am.
Okay, so we will continue. Next is relation between gravitational field and gravitational potential. Same formula as in electrostatics. Okay, so gravitational field is equal to minus dV by dx, or negative gradient of potential is gravitational field, and reverse if we are taking, we can write as V equal to minus integral E dot dx. So this is our equation similar to that work done we calculated. Instead of F we just write E. Okay. And in 3 dimension you are not familiar with this equation, but this is only like with x coordinate, right? But usually it is in 3D, like there will be x, y and z. Then how do we write this? So E will be equal to minus of dou V by dou x I cap plus dou V by dou y j cap plus dou V by dou z k cap. Are you familiar with partial differentiation? Are you covering that in differential equations or something? Okay. So this is partial differentiation. Okay, so actual formula for E will be this, and this thing we do, it is considered as an operator, that's why we can write as minus of del V. This dou by dou x I cap, those things are del operator, that's why this formula is coming. Okay, but for us like numericals in entrance will be enough with this formula. Okay, we don't need this one. Coming to the next topic. So for some objects we have to know what is gravitational field and gravitational potential. So for that I have considered this. For point mass we already derived this. Gravitational field Gm by R square, gravitational potential minus Gm by R. Okay. Now coming to spherical shell. Shell means inside is hollow, nothing is there, empty, only surface will be there. There two cases are there, outside and inside. Okay. See this one same, we did this for electrostatics also, right? For different shapes, what is electric field outside and inside a sphere, and what is potential outside and inside sphere, same formulas only. So outside you can see gravitational field is Gm by R square, then potential is minus Gm by R, inside field is 0, inside potential is minus Gm by R. Okay, one more case in surface E equal to Gm by capital R square and V equal to minus Gm by R. So this is one additional thing. Now if it is solid sphere means like earth and all, in that case outside no change Gm by R square, in potential also there is no change, but when we come to inside, gravitational field is Gm small r by capital R cube. Small r is like if you are taking this as the solid sphere, this is capital R, and if we are taking this point, this distance is small r. Okay, screen is not clear. It will be corrected now, don't worry. It's
దీన్ని అసలు నోట్లో ప్రిన్సిపల్ సార్
ഈ ഊള കറണ്ടിന് വേറെ പണിയൊന്നുമില്ലേ? കറണ്ട് പോകുന്നതുകൊണ്ടാണ് ഇത് ഫ്ലക്ച്വേഷൻ വരുന്നത്. വേണ്ട വേണ്ട, പിന്നെ അത് ഓൺ ചെയ്യാൻ മറക്കും. ആ ഇത് ജെമിനിയാ. ആ വേറെ നല്ല ടേബിൾ കിട്ടുന്നുണ്ടായിരുന്നില്ല. Hello, is it audible now? What about screen? Okay. Okay, so what I was saying was, if this is the solid sphere we are taking and r is its radius, and this is the point where we are calculating field and potential, distance to that point is small r. Okay, that's why gm small r by capital R cube, and field will have this equation. Okay, sorry, potential will have equation minus gm by 2r cube into 3r square minus small r square. Okay, so please learn these formulas. Now, not just this formula, you will need to know the graph also, like inside what is potential, how electric field will change inside and outside the sphere. But the twist is that we can use the same graph which we learned in electrostatics here also. In electrostatic we are learning graph, how field is varying inside and outside, all those things. That same graph we can apply here also, there is no change. Okay, now coming to other things, you can see that for uniform ring on axis, what is field? This is field and this is potential. Okay, field and potential, you can compare this equation with electric field and potential due to a ring. Okay, same formulas, only we are only replacing the quantities. Instead of k it will become g, instead of q it will become m. That's it. Now for a line mass distribution, okay, for a road or something like this, then mass is m and length is l, then we can say lambda is equal to m by l. Okay, mass per unit length is lambda, and at distance r, what is field and what is potential? Here c is a constant. Okay, we for, as you already know, for a line mass distribution we cannot find potential at a point, we can find potential difference. Okay, so that's why this extra c is coming. If you are finding potential difference, you will know 2g lambda log ri by rf or rf by ri, like that it will come. Okay, is there any doubt? Again, it's not clear. Okay, how about now? Is it better? Is it better now? No.
Keep it there only. I think here it will bring.
Screen and audio proper. Am I audible? No. Okay, it's fine. Screen is fine. Okay, then we will continue. Okay, so h is height of the object from the surface of earth. If h is very small compared to this re, then we can use this formula. Okay, but if h is comparable to r radius of earth, like h is equal to 2 re or r by 3, like that it is given, you can't use this formula. Then you have to use the formula, that is gh equal to g divided by re plus h, sorry, small difference, g equal to gm by re plus h the whole square. You have to use this formula. In this also you can convert it like this: gm by re square into 1 by 1 plus h by re the whole square. So gm by re square is our acceleration due to gravity g. So gh will be equal to g divided by 1 plus h by re the whole square. So if h is very small, use this formula. H is comparable to radius of earth, use this formula. Okay, if you use this formula in that, you will not get the correct answer. I hope that is clear for all. H very less than re, this formula. H comparable to re, this formula. Is that clear? Okay. Now at a d depth from the surface of earth. Okay, in that case our formula is g into 1 minus d by r. Here d is not you are not going to get like d very big or something. This formula is applicable when d is very small than re. Okay, radius of earth. Here much variation you won't get. You can directly apply this formula. There won't be any issues. Okay, is that clear? So at h height from the earth you have two formulas. One is when h is small, next one is when h is like comparable to radius. At a d depth from the surface, if you are digging down into the earth at d distance, this will be the formula. There you don't have two equation, only one equation. Is that clear? Okay. Coming to variation of g due to shape of earth. As you know, earth is not a perfect sphere. It is a geoid shape, which means it is like radius is more at the equator and radius is less at the pole. And as you know, acceleration due to gravity equation is gm by radius of earth square. So when radius increases, what happens? G will decrease, right? And radius decrease means g will increase. That's why minimum weight is at poles and maximum weight is at minimum weight it is at equator. Okay, minimum weight is at equator and maximum weight is at poles. I hope you are clear. Last slide. This one. What is the doubt? Here gm by r square we wrote as g, acceleration due to gravity g, 9.8, that value. Here also g is 9.8 meter. So we are finding at h distance. Is that okay? Okay. So here weight is minimum at equator and maximum at poles. Along with that, due to rotation of earth, there will be variation in g. Okay, if you see that at any point you take on the surface of earth, what happens? Like at the surface, if you are this, towards the center you have mg acting. Okay, and towards outwards, perpendicularly up, you have normal force also. Normally what we will say mg equal to n in this case, but it is not, because due to rotation of earth. Okay, so this is the axis of rotation for earth and it is at r distance. Okay, this is center of earth, this is capital RE. See the difference? Small r is distance from the axis of rotation, capital R is radius of earth. Okay, so due to the rotation there will be centrifugal force, right? We learned about centrifugal force which is acting outwards in this direction. Okay, centrifugal force is equal to m omega square r, or mv square by r we wrote in terms of omega, that's it. Now it will have components. Those components will be perpendicular one and parallel one. Okay, tangential to the surface of earth and perpendicular to the surface of earth. Tangential component will not change our weight or anything, will not change the value of g, but perpendicular component will change. Okay, how to find that perpendicular component? If you consider this angle to be phi, okay, this angle to be phi, it is same as we use in magnetostatics, dip and all we are saying, no, same phi only. If we are taking this angle as phi, we can say this angle will be phi. So component along this is m omega square r cos phi. Here it is small r, remember that. Now coming back to this, comparing r and re. If this is phi, this is also phi, right? So can I say that cos phi equal to opposite by hypotenuse? So from this we will get small r equal to re cos phi. Okay, we can substitute that value also here. So if you take net force, F net for the person, there will be mg acting downwards minus n, then what will be there? mg minus m omega square r cos phi. This will be net force. So n will be equal to this. Okay, so if I am calculating, F net will be equal to m into new value of g, acceleration due to gravity. That we can say mg minus m omega square r, we will substitute re cos square phi. We can cancel m along the equation, we will get g dash equal to g minus omega square re cos square phi. Okay, due to rotation of earth, this will be new acceleration due to gravity. Is there any doubt in this? Like we are considering, is centrifugal force not radial away from the radius? Yes, centrifugal force is away from the radius, but away from the radius of rotation, right? Like earth is not rotating about the center, it is rotating about an axis. So if we are rotating like this, from the axis we are calculating the radius. Okay, not the radius from the center. Both are different. Centrifugal force is true away from the like along the radius away from axis, but we are considering radius to the axis. I hope that's clear. Okay. In this also you will need only this formula. The whole derivation I just explained for that you don't get the confusion. Okay. I hope we can move on. Now coming to escape velocity. Is the screen a little not visible for you all? Okay, screen is not visible, no problem. I will just write the formula. Okay, escape velocity, how we are finding is, only one method is there, that is conservation of energy. Energy at the surface should be equal to energy at infinity. Why infinity? Because gravitational force of earth is 0 at infinity. So energy on the surface of earth should be total energy at the infinity. Energy at the surface will be potential energy minus gmm by re square plus half m escape velocity square. Potential energy plus kinetic energy on the surface equal to potential energy at infinity. R equal to infinity, if we put, it will be 0. So potential energy at infinity is 0 plus, if you are taking escape velocity, we are just taking velocity from here to infinity. After that it doesn't have to move. So velocity at infinity also 0. Okay, so total energy is 0 at initial and final points. That means that half mve square should be equal to gmm by re square. If you cancel this m and all, we will get escape velocity equal to root 2 gm by re square. Okay, this is the equation for escape velocity of earth. This value we get approximately 11.2 kilometer per second. Okay, this is the case when we are throwing with a constant velocity from earth. Again we are not giving any other force. Rocket and all are not moving this velocity because they are constantly providing force to escape the gravity. Okay, so both are not same. Escape velocity from earth we will give some force, along the way we are not giving any other extra force. Now this same equation you can use for other planets also. Let's say escape velocity for Mars will be equal to root 2g mass of Mars divided by radius of Mars the whole square. Okay, so same formula only, you can repeat the same formula for different types of objects. Okay, for moon, for sun, everything you can use same formula only, replace mass and radius. So what do you understand? This escape velocity depends on the mass of the planet, radius of the planet, but it does not depend on the mass of the object. Okay, like if you want to throw yourself or a ball, escape velocity is same for both. Okay, is that clear? Okay. Now coming to Kepler's law. Okay, coming to Kepler's laws, there are 3 laws. First law is about elliptical orbit. Okay, first law is about elliptical orbit, which means everything is rotating in an elliptical orbit, but and sun is at one of the foci. All planets are orbiting in an elliptical orbit with sun presenting at one focus. Okay, since you already studied conic sections and all, you know that there are 2 focus for an ellipse. Circle has one center, 2 focus for ellipse. In one focus sun is present. That is first law of Kepler. Okay, second law second law is aerial velocity constant. Aerial velocity constant. Okay, aerial velocity is change in area by time. Okay, dA by dt or delta A by delta t, both are correct. Aerial velocity. Linear velocity, distance by time. Aerial velocity, area by time. This is a constant value. Okay, this value we are getting as L by 2m. L is angular momentum. Angular momentum by 2m we are getting the value of aerial velocity. If that is constant, then can we say that L will be constant? Angular momentum is constant for for rotation, like due to the planet motion. For every planet, angular momentum is constant. Okay, is that clear? That is from second law. 2 points we are learning. One point is aerial velocity constant. Its formula will be L by 2m. From that we will again get that angular momentum is constant. That is second law. Now coming to third law. Third law, it is about time period. Okay, it is about time period, and what is it saying? Time period of rotation of planet, square of that is proportional to cube of the radius. Okay, they have explained in different way, like cube of the semi major axis, but that is if it is a complete ellipse, there is a like major axis and minor axis. So say major axis half is there, cube that, you will get time period square. But here when we are applying for entrance problems, you can use like this: t square proportional to r cube. R is the radius of rotation. What is the reason for that is, even though it is ellipse, it is barely ellipse. Okay, do you know like 0 is the eccentricity of circle? Okay, and for ellipse it is between 1 and 0. So eccentricity of orbit of earth is 0.00 something. Okay, it is very close to a circular orbit. That's why instead of semi major axis we can use radius. I hope that's clear. First law, second law and third law of Kepler's. Okay. Now coming to orbital velocity. Escape velocity is different, orbital velocity is different. Okay, orbital velocity is if a satellite is orbiting around Earth, what is the velocity of that? Okay, as given here, you can get that orbital velocity is equal to root gm by r. Okay, how we are getting that formula? Sorry, one second. I wrote r square here, that is a mistake. Okay, potential energy, right? Potential energy is just r. Okay, not square. Please note, there is no square here. Potential energy we are calculating, there is no square for r anywhere. Okay, you can actually compare this formula with the orbital velocity. In just don't need to put 2 here. Escape velocity is root 2 gm by r. Orbital velocity is root gm by r. Okay, r will be radius of the like the orbit it is following. There r is radius of earth, here r is radius of the orbit. Okay, how we are finding that? We are putting centripetal force equal to force of gravitation, because if an satellite is orbiting the earth, only force present is gravitational force. So we can equate that mv square by r is equal to gmm by r square. Here it is force. Okay, comparing we will get cancel this, cancel m, we will get orbital velocity equal to root gm by r. This is the formula. If we get orbital velocity, we can find total energy of the satellite. total energy of the satellite is equal to potential energy plus kinetic energy. Okay, potential energy is minus G capital M small m divided by R, plus kinetic energy is half m v orbital square. If you substitute the kinetic energy, what is the value? That is G m by 2R you will get. Okay, this is kinetic energy, VO I am substituting here. Now if you are getting total energy will be equal to minus Gmm by 2R. Okay, actually total energy of the satellite is equal to hey, why?
School. 1 month.
Is it visible and audible? I hope in between it was lost. It's not proper. Just give me a thumbs up if it gets better, okay? In that case we can continue, okay? So substituting potential energy and kinetic energy, we will get total energy equal to this. Can you compare these? We can say that total energy is equal to negative of kinetic energy. One comparison. Another comparison is total energy is potential energy by 2. So remember this. Okay, total energy of a satellite is negative of kinetic energy, or total energy is equal to potential energy by 2. And final formula also. Is this clear for all? This is the last topic for today. We will start PYQs then. Not audible. In the?
Tell the students to wait for 5 minutes. They are repairing the Wi-Fi problem.
അല്ല അവർക്ക് കാണുന്നുണ്ട്.
കേൾക്കുന്നില്ലല്ലോ.
അത് ഞാൻ മൈക്ക് ഓഫ് ചെയ്തു.
എനിക്കൊന്ന് വൈഫൈ ഇല്ല, വൈഫൈ കണ്ടില്ല. അവിടെ ഒരു വൈഫൈ ഫുൾ.
Hello, am I audible? Okay. What I was saying was total energy is equal to negative of kinetic energy and total energy is equal to potential energy by 2. From the formula we are getting that. Okay, that is the last topic. Next we will start the PYQs only. Is that like everybody understood? Can we move on to PYQs? Okay. So this is from NEET 2025. Please read the question. The radius of Martian orbit, which means orbit of Mars, around the Sun is 4 times the radius of orbit of Mercury. 1 Martian year is 687 Earth days. Okay, 1 year in Mars is equal to 687 Earth days. Which of the following is length of 1 year on Mercury? So 1 year means time period. Okay, 1 year means time for 1 revolution, that is time period. Time period of Mars is given. We have to find time period of Mercury. Relation between radius of Mars and Mercury is given. So we have to use Kepler's third law here. Okay. Okay. So time period of Mercury, we have to find time period of Mercury by time period of Mars, the whole square, is equal to radius of Mercury divided by radius of Mars, the whole cube. This is the formula. Try by yourself and tell me the answer. Yes, option C is the answer. I hope you guys are doing and not searching the question and saying the answer. So what we are doing is, time period of Mercury will be equal to radius of Mercury by radius of Mars. It is equal to 1 by 4. So 1 by 4 the whole cube into time period of Mars. Okay. So this is equal to 687 divided by 8. Sorry, 3 by 2 will come. Okay. 3 by 2. So by 8. You will get approximately 85.8. So the closest answer is option C. That's why we are taking this. Okay. Is that clear for all? Okay. Then we will go to the next question. Next one. A body weighs 48 Newton on the surface of Earth. Gravitational force experienced by the body at a height equal to 1/3 of the radius of Earth from its surface. Okay. So here weight is equal to 48 Newton. Okay. How we are getting that? That is equal to m into g at the surface. Now we have to find weight at 1/3 height of from Earth. Okay. So that weight, new weight will be equal to, as I told you, m into nu g or g at h height. Since here h is given as RE by 3, it is comparable to radius of Earth. It is not very small. Which formula we have to use? G divided by 1 plus h by RE the whole square. This formula we have to use since h is comparable to radius. Substituting here, you will get 1 plus 1 by 3 the whole square, that is 48 divided by 3 plus 1 by 3 the whole square. You will get 48 into 9 divided by 16. Okay. So what will be the answer? But it is less than radius. It doesn't mean it should be less than value of radius. Okay. Comparable to the radius of Earth. Okay. That is the case. Not less than radius, very much less than radius. Like radius is 6,400 kilometer. If h is equal to 1 kilometer, it is very small, right, compared to r. Then you can use that. But r by 3 means 6400 by 3. It is a big value which we can compare with the radius. That's why we are using this formula. I hope everybody understood. 27 Newton is the correct answer. Okay. Next one, escape velocity of Earth is v. A planet having 9 times mass of Earth and radius. Okay. Radius 16 times of Earth. What is the escape velocity? Escape velocity on Earth we will get by 2g m mass of Earth by radius of Earth. This is the formula. Now if you want to find at any planet, it will be root 2 g mass of that planet divided by radius of that planet. We can compare that mass and radius with Earth. Then we can substitute Vp is equal to 9 times mass of Earth. Okay, so root 2g 9 times mass of Earth divided by 16 times radius of Earth. So 9 by 16 we can take outside. It will become root 9 by root 16, that is 3 by 4, then V. So 3 by 4 V is the answer. I hope that's clear for all. When you take it outside, you will get root 9 by 16 into root 2g me by re. So this we are substituting as V. Is that clear for all? Answer is option C, 3 by 4 V. Okay. Next one. An object of mass 100 kg falls from point A to B. Okay, this is point A, they haven't mentioned. A to B as shown in the figure. Change in its weight corrected to the nearest integer. Okay, whatever value you are getting.
Change the network to TP. It's connected UPS, no problem.
Okay, whatever value you are getting, you have to like round off into nearest integer. So like whatever net issues we were facing, we have sorted that out. Don't worry, it won't happen again. Okay, so we have to find mg at point A and mg at point B, then find the difference. Okay, so basically what we have to find, m into gb minus ga or ga minus gb, comparing like which is bigger value. Okay. Now at point A, what will be g? Since it is comparable to radius of Earth, we have to use which formula? G divided by 1 plus h by re the whole square. This formula you have to use. So, and to point A, distance is 2 re. So h will be 2 re, 1 plus 2 the whole square. It will be g by 9 at GA. Okay. Now GB will be at point B. If you substitute, this is HA, 1 plus HB by RE the whole square. Okay. HB, this distance is given as R by 2. Okay. So from B to ground, this distance will be 2R minus R by 2. That will be, okay, this distance will be equal to 2R minus R by 2. That will be equal to 3R by 2. Substitute that here. So 1 plus 3 by 2 you will get. So this will be 16 by 25 G. I hope you are doing the calculation along with me. Substitute these two values in here and find the answer. You can use G equal to 9.8 or 10. Both are fine. Anyone got the answer? So this will be equal to 100 into 100 g into 1 by 9 minus 16 by 25. Okay, g you can take as 9.8. Nobody is doing the calculation, very bad. Okay, answer you will get as 49 Newton. I am skipping the calculation part because we don't have time. We have to solve more questions. But is the method clear for all of you? How we are doing? I am not getting any response from your side, so I am having doubt if you are understanding or not. Is it visible and clear? Okay, can we move to the next problem? Okay. Okay, next one. Mass of a planet is 1 by 10th of Earth. Diameter is half of Earth. We have to find acceleration due to gravity on that planet. Acceleration due to gravity equation is gme by re square. Okay, at that planet acceleration due to gravity will be g mass of that planet divided by radius of that planet square. Okay, now substituting it with mass of Earth and radius of Earth, 1 by 10th of mass we have for mp. Okay, so g me by 10 will come. Then diameter is half of the Earth, so radius also half of Earth, so re square by 4. So this is equal to 4 by 10 g. Okay, substitute g equal to 9.8 meter per second square, you will get the answer. Yes, correct. Option D is the answer. Very good. Okay, so can we move to the next question then? Okay. Next one. Minimum energy required to launch a satellite of mass m from surface of Earth. Earth mass is given as capital M and radius r to a circular orbit at altitude of 2r. Okay, so energy required, like this is the surface of Earth from re distance, from here to, from this distance is given as 2r. Okay, from to this point we have to launch something, we need the minimum energy for that. Wait a second, you try your own, then I will give the answer. Charge, I was putting. No. Were you guys able to do anything? Like minimum energy we want. Okay, so how we find is that we need the kinetic energy from here which we will launch so that it will reach here and it will start orbiting. Okay, it's a satellite, right? So potential energy at surface plus kinetic energy at surface should be equal to potential energy in the orbit plus kinetic energy in the orbit. Okay, potential energy at the surface will be minus g small m divided by capital R. Kinetic energy is at the surface is what we have to find. Okay, then potential energy at the orbit. Orbit is 2r from the surface of Earth. So total distance is 3r. Okay, potential energy at the orbit will be gmm by 3r. Okay, that will be the mistake you might do. You will substitute 2r there, but from center of Earth we have to see, that will be 3r plus kinetic energy at that point. There it is having orbital velocity, right? Orbital velocity is equal to root g m by r, radius. So substitute that. So you will have half g mm by radius is equal to 3r. So 3r. This will be the formula. You have to solve for kinetic energy at the surface. Solve first. All the values I have given. You have to find kinetic energy at the surface of Earth. Is there any doubt in this question anyone having? Like you did not understand any theory or concept? Are you guys solving or waiting me to answer? Because I need to save time, that's why. Okay, very good. Surabhi, answer is option A. Okay, answer is option A, 5 gmm by 6r. Okay, we will move on to the next question then. Next one, escape velocity of a body on Earth's surface is 11.2 km per second. If the same body is projected upward with velocity 22.4, velocity of this body at a distance, infinite distance from the Earth. Okay. Escape velocity means if we are throwing that with that velocity from Earth, at infinity it will go and stop. Okay, infinity velocity will be 0. But we are throwing it with more velocity than escape velocity. So there will be some velocity at the infinity that we have to find. Okay, so what we have to do is, like, potential energy plus kinetic energy at surface will be equal to potential energy plus kinetic energy at infinity. This we have to find. Okay, potential energy at the surface minus gmm by r. Kinetic energy is given as half m, let's take this as v square, equal to potential energy at infinity 0 plus half m v infinity square. Okay, v infinity we have to find. That is the question. Now, since other values are not given, okay, can I write that half m v orbital square is equal to, not orbital, sorry, escape velocity square is equal to g mm by r. Can we write that? Because escape velocity we are deriving like this, right? So I can substitute like g mm by r as half m ve square. So half m escape velocity square plus half m whatever velocity is given square is equal to half m v infinity square. Half m is common in like common everywhere, so we can say we can cancel this out. Okay, and we will get v infinity is equal to v square minus ve square the under root. Okay, so v square is equal to 22.4 the whole square minus ve square is 11.2 the whole square. If you find this value, you will get the answer. Yes, very good. Surabhi, option D is the answer. Okay. I hope everybody understood this. So basically energy conservation is very important. We have to apply that energy conservation equation in so many questions. Okay, so be thorough with that. Next question. If r is the radius of earth and g is acceleration due to gravity on earth's surface, then mean density of the earth will be. You have to find density of earth. See, density is equal to mass by volume. Volume I can write as 4 by 3 pi r cube, right? And mass, how we can get? We know that acceleration due to gravity is the other thing which is given. G is equal to g m by r square. Okay, from this we will get that mass is equal to g r square divided by capital G. Okay, so mass by volume we have to find. Okay, so density is equal to g r square by g divided by volume 4 by 3 pi r cube. What will be the answer? Is 4 pi coming in the numerator? This is what I am getting. Okay, so answer is option C. Yes, very good. Okay, we will move on to the next question then. Is that clear for all? Okay. Next one, graphical question. These are like must do questions. Okay. Starting from the center of earth having radius r, variation of g you have to find. As I told you, what is g? G is g m by r square. This is same as our gravitational field, right? So variation of field with respect to distance r, that is the graph we have to find. D, B, so many are coming. So earth is like a solid sphere. So we need to find the graph of a solid sphere, electric field varying with the distance. That answer is this, option B. Okay, electric field with respect to distance graph is this, and since we are doing, I told you graphs are same, we can choose this answer. Option B is the answer, not D. Okay. Next one, ratio of escape velocity of Earth to escape velocity of planet VP, whose radius and mean density are twice that of Earth. Let's see. You have to find VE by VP. Okay, VE is equal to GME by RE, 2GME. Okay, VP will be equal to 2GMP by RP. Root 2G we can cancel, we will get root of ME by MP RP by RE. Okay. Now density they have given as twice. Density twice, radius twice. So we have to write mass of Earth is equal to density of Earth into 4 by 3 pi radius of Earth cube. Mass of planet P is equal to 2 times density of Earth, density of that planet, into 4 by 3 pi, radius of planet is twice, so RE square into 4. Okay, so you will get mass of this planet is equal to 8 times mass of Earth, and RP is already given as 2RE. Now substitute the values and you will get the answer. Anyone got the answer? Ratio? Yes, not B. You will get 1 by 4. You might have made some careless mistake here. If you substitute, you will get 1 by 8. From this you will get 2. 2 by 8 is 1 by 4. Root 1 by 4 is 1:2. Yes, C is the answer. Okay. We will move to the next question then. This will be the last question for today. The ratio of escape, this is the answer. Okay, sorry. That's a mistake. Okay. From what height from the surface of Earth the gravitation potential and value of G are? This is gravitational potential and G. We have to find at what distance this value is there. Radius of Earth is given as 6400 km. We know that potential is equal to Gm by R. Like magnitude I am taking, not the, this is just magnitude, not the like negative sign I am not taking. G equal to Gm by R square. We want to find R, right? So we will find V by G. V by G is equal to R. This is distance from the center of Earth. Okay. R will be distance from center of Earth. V is given, G is given. Now if you want to find from the surface of Earth, R minus 6400 if you do, you will get distance from surface of Earth. Substitute and find. Did anyone get the answer for this? Actually minus 5.4 into 10 to the power 7 divided by 6. so that you will get as 0.9 into 10 to the power 7. Then if you are writing in kilometer, this is given in kilometer, you will get R equal to 9000 kilometer. So H will be equal to 9000 minus 6400. Yes, 1600. Check again. Actually, option C is the answer, 2600 kilometer. Yes. Okay, so I guess we can stop our class here for today. There are like 2-3 more questions I have added in the PPT. I will send to you guys. Solution I am not sending in the same day, because instead of solving by yourself, you will directly check the solution. Okay, that's why I am not sending the solution. Please solve yourself and check the answer in the Google. If it is not matching, then I will give you the solution. Okay, then take 30 minutes rest. There will be chemistry class from 12 to 1:30. Please join on time. Okay, you can leave the meeting.